Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0137 indicates an issue with the secondary heated oxygen sensor, HO2S, specifically its second sensor, which is experiencing low voltage in its circuitry. The secondary HO2S, also known as the downstream O2 sensor, is crucial for monitoring the efficiency of the catalytic converter and ensuring optimal engine performance. Located typically after the catalytic converter, this sensor provides feedback to the engine control module, ECM, regarding the exhaust gas's oxygen content. The primary function of the sensor is to help maintain a proper air-to-fuel ratio by sending signals that reflect the exhaust's composition. In a well-functioning system, the voltage generated indicates how rich or lean the exhaust gases are, which is vital for the vehicle's emissions control. When the DTC P0137 arises, it often suggests that there's an issue with the sensor itself or the wiring connected to it, necessitating a thorough inspection and troubleshooting process. DTC P0137 refers to the secondary HO2S circuit registering a low voltage condition. The secondary HO2S, or the downstream oxygen sensor, is integral to the vehicle's emissions management system. It is positioned downstream from the catalytic converter, where it measures the oxygen levels in the exhaust gases after they have passed through the converter. The sensor's readings help the engine control module, ECM, manage fuel injection and monitor catalyst efficiency. If the voltage from this sensor drops below the expected threshold, this may indicate a malfunction either in the sensor itself or in the circuits connecting it to the ECM. It's essential to check both the sensor's integrity and the surrounding wiring for any possible damage that might cause low voltage conditions. The potential causes of DTC P0137 include several key components that could lead to low voltage signals from the secondary HO2S. A primary suspect is a faulty secondary oxygen sensor itself, which could be worn out or malfunctioning, leading to incorrect readings. Wiring issues are another significant factor. Damaged or corroded wires connecting the sensor to the ECM may disrupt proper signal transmission. Moreover, loose or corroded connectors can impede electrical contact and result in low voltage readings. It's critical to investigate these areas thoroughly, as any faults in wiring or connections are often responsible for erroneous DTC signals, such as P0137. By addressing these components, you can methodically eliminate the root causes of the issue. The presence of DTC P0137 typically results in several noticeable symptoms for the vehicle owner. The most immediate is the illumination of the check engine light, CEL, alerting the driver to a potential issue that requires attention. Additionally, drivers may observe a decline in fuel economy due to improper air-fuel mixture adjustments resulting from faulty sensor readings. Another symptom could involve increased emissions, which may cause the vehicle to fail emissions tests, leading to legal and financial repercussions for the owner. Lastly, erratic engine performance might be experienced, such as rough idling or hesitation during acceleration, as the engine attempts to compensate for incorrect data from the secondary O2 sensor. Recognizing these symptoms early can aid in timely diagnosis and repair. In the first troubleshooting step for diagnosing DTC P0137, it's imperative to ensure the vehicle is in the on mode, which powers the various electronic systems necessary for diagnostic checks. Following this, the Honda Diagnostic System, HDS, is used to clear the existing DTC. This approach helps in resetting the onboard computer and allowing for a fresh read of the current conditions. Next, the engine should be started and allowed to idle, preferably in a no-load condition, such as in park, CVT, or neutral, MT, until the radiator fan engages. This could take several minutes and is critical for stabilizing engine conditions. Monitoring the OBD status via the HDS is essential to determine if the DTC P0137 reoccurs. If the HDS indicates that the DTC has failed again, it confirms a persistent issue requiring further investigation. If it shows past, then there may be intermittent issues or loose connections that need examination. For the second step in troubleshooting DTC P0137, the process begins by turning the vehicle off and securing it to prevent accidental activation. The secondary HO2S, specifically its 4-pin 4P connector, must be disconnected to isolate the sensor from the vehicle's electrical systems. Once this connector is detached, the vehicle should be powered back to the on mode. This allows the technician to utilize the HDS to assess parameters related to the secondary HO2S. The HDS will provide readings for the voltage levels, which should ideally be below 0.17 volts under designated conditions. If these readings align with the specified threshold, it confirms the test conditions are valid and indicates a potential fault isolated to the secondary HO2S sensor. If the readings do not match, it hints at a sensor failure, warranting its replacement. In Step 3, begin by turning the vehicle back to the off lock mode. This is a safety precaution to ensure that no power is supplied to the systems while performing continuity tests. Next, testing for continuity between specified test points is essential for diagnosing potential short circuits. The first test point is the secondary HO2S Sensor 2 4P connector's male terminal number 1, while the second test point is a body ground location. This check will indicate if there is a short circuit in the wiring. If continuity is found between these points, it suggests a short circuit along the SO2 line. Thus, the troubleshooting can be directed towards identifying and repairing that short. In case there is no continuity, it implies the wiring integrity is good, necessitating the next step of checking the overall system for other possible faults or data sources. In troubleshooting Step 4, the vehicle must have the SCS line jumped using the HDS for short circuit testing. This process involves enabling a state where the system can be assessed for shorts without interference. After waiting for more than 1 minute after jumping the line, the PCM connector A, which has 50 pins, should be disconnected. This disconnection prevents any signal interference from the PCM, while continuity between specified test points is examined. The same test point used in the previous step, HO2S 4P connector male terminals, is again evaluated against body ground. Finding continuity through this check indicates a likely short in the SO2 wire running between the PCM and the secondary HO2S, which would need repair. If continuity is negative, the wire remains intact, leading to further investigation, either in service guides or by testing with a known good PCM to ensure sensor performance. In the final step of troubleshooting DTC P0137, the same initial steps as in Step 4 are required with regards to jumping the SCS line and disconnecting the PCM connector A. Following the SCS line jump and waiting for more than 1 minute, it becomes crucial to verify continuity at another set of test points. This time, focus on the second terminal at the secondary HO2S Sensor 2 4P connector while comparing it to body ground. This method helps identify if there is a short within the SO2SG line. Continuity at this stage would suggest necessitating repairs on the SO2SG line running between the PCM and the secondary O2 sensor. If no continuity is found, it confirms that the SO2SG wire is functioning correctly, directing technicians to evaluate other DTC references or considerations. If a known good PCM is substituted and resolves the issue, the original PCM should be replaced. After completing the necessary repairs in response to DTC P0137, the final verification of those repairs is vital to ensure the integrity of the system. Utilizing the HO2S, rechecking the DTCs will confirm whether the issue has been resolved. It's important to monitor the vehicle in various operating conditions to assess engine functionality and VOT readings for stability. If any issues arise during this verification phase, further inspection may be required. Once satisfied that the resolved repairs are effective and no new DTCs appear, the last step involves clearing the DTCs to reset the vehicle's computer. This process assists in restoring normal function to the vehicle's electronic systems, while boosting the owner's confidence that the problem has been adequately addressed. Preventive maintenance is crucial for avoiding future occurrences of DTC P0137 and ensuring the long-term health of the vehicle's emission system. Regular inspections of the oxygen sensors, especially the secondary HO2S, can help identify early signs of wear or malfunction before they escalate into more severe issues. Electrical connections should also be monitored routinely for any signs of corrosion or looseness, as these can lead to intermittent faults that may trigger DTCs. Implementing routine engine diagnostics can assist in maintaining optimal performance and catching potential errors before they affect emissions output. Keeping the vehicle's electronic systems updated and in check greatly contributes to compliance with environmental regulations, while enhancing fuel efficiency and overall performance. In conclusion, understanding DTC P0137 is crucial for maintaining the emission integrity of the Honda Civic model from 2016 to 2021. This code highlights specific issues related to the secondary HO2S circuit that can have broader implications for engine performance and emission compliance. Tackling DTCs requires a systematic approach, first acknowledging symptoms, and then delving into structured diagnostic procedures to isolate and resolve the underlying causes. Regular preventative maintenance provides an additional layer of protection against unexpected DTCs and maintains vehicle efficiency. By ensuring the oxygen sensors, wiring, and connectors are in optimal condition, vehicle owners can enjoy improved fuel economy, reduced emissions, and a smoother driving experience, ultimately safeguarding both the vehicle and the environment. Please like and subscribe to the channel. See you next time.